So, hey everyone, good evening. I'm Ido from LivePerson. I'm a group leader at LivePerson. And we've been using Couchbase for about 5 months or so. So we wanted to share a little bit about like a story, what we did, our experience, some of the insight that we started to kind of gather. And I'll let you guys ask questions throughout the presentation and afterwards as well. So I made a small connection. I'm going to walk you through a little bit what LivePerson does, what are the numbers or the volume that we're dealing with, kind of what's the story of this system, where we started, where we're going, and why did we choose Couchbase, and a little bit about the architecture and code and production. And as Tuck said, we're going to leave a Q&A time at the end. Just feel free to ask questions throughout the process. So a couple of minutes what LivePerson is for people that don't know what LivePerson is. We're the leading customer intelligent engagement platform. Essentially, we're helping our customer communicate and engage with their customers. We've been doing software as a service since '99. Back then it was called ASP, but it's essentially the same thing. Just for people that really don't know what LivePerson is, so this is probably the most obvious thing about LivePerson, which is the live chat window. But today we do non-human type of engagement and mobile engagement, et cetera, et cetera. So when it comes to the technology stack, we're heavy on the JVM, a lot of Java code, Scala code as well. We do Linux, commodity servers, and we have, LivePerson has 4 data centers in the world. Today we're running all of those data centers on private cloud that they are based on OpenStack. Sorry. So just data and numbers about LivePerson. You see the numbers here. We're doing about 1.8 billion visitors sessions a month. It's a lot of traffic, a lot of data. We have some people here from our data platform, so they can tell you they're dealing with this amount of data all the time. As far as like the stack on the data side, we do use relational databases. Oracle is our kind of legacy. We do also MySQL. We're doing Hadoop for many years. Cassandra we've been doing for many years. And recently we adopted Kafka and Storm, both are open source products, LinkedIn and Twitter. So we're doing that for the last 8 months or so, give or take. I want to kind of first tell you a little bit about like the use case itself, what we're doing, what we're looking for. So the use case that we're dealing with is something called a visitor list, which is a real-time analytics system for our customers. Remember, LivePerson is a SaaS platform, so we have about 8,500 customers. They're all using the same system, and we help them essentially monitor the visitors on their sites. I have to get rid of next time Skype. So what does it do? Okay, so as I said, LivePerson is a SaaS platform, so we have customer representatives or agents that actually use LivePerson on one side, and on the other side you got visitors that comes into the digital properties, website, mobile devices, and they're browsing their sites. On the other hand, we got the agents, the customer representative of the customers. So this system, this product that you see here, essentially provide them visibility into their online concurrent visitors. This product exists in the market for a few years, but you need to understand that this is the only tool for some of our customers, especially in the SMB market and some in the enterprise market. This is the only tool that provides them in real time the ability to see who's browsing their site and the ability to engage with them. And this product is being used by thousands of agents as users, thousands of agents all across the world, people that sit in call centers all across the world. So I'll tell you a bit what I call the story, kind of once upon a time, and our transition in the technology stack, and why we had a problem, and how did we solve that problem. So back in kind of talking about the old days, okay, the way that this product started. So in the old paradigm of LivePerson legacy, some people say, We have the website, visitors. We have a system that essentially monitors events, and we have what LivePerson called the app server, which is a stateful web server. Those machines are usually vertical. As far as scalability, they're vertical scale. Very large machine, RAM, everything is being held in memory. These servers have been used to many purposes. And the way that it works, we had what we call the agent console, which is essentially a Java app that essentially communicate with the server and get information all the time. So you can see visitors on one side. All those visitors have been monitoring in this monolithic server, and that server keeps sending changes to thousands of Java consoles around the world and tell them and communicate with the changes that goes on with the visitors. LivePerson has kind of restructured some of its technology stack, and we moved to a system when we have multiple web server, web tier, or monitoring services that scale horizontally. All of the architecture of LivePerson today is a service-oriented architecture, API, REST, and all distributed. And the problem that we had is that now we have web servers or monitor servers that reside all across the farm and across farms, and they're monitoring the visitors from kind of all across the web. So we needed to gather the information. Now the information is not stored in one single server, and we had to basically essentially gather all of that information in real time or near real time. And the way that we do that, we have a new, on LivePerson, we have a new event bus using Kafka and Storm, two open source product. And now on one hand, we had all the events streaming in those very fast event bus. And on the other hand, we have a new console. We call it the web agent. It's all web-based. It's not a Java app anymore. So it's a web interface to essentially provide the same functionality that we had in the old platform. But now we needed a system that can aggregate all of that information, all of those thousands of events every second, and we had to collect that into a system. And that's where our use case came, and that's where we started to look for options. So when we searched for possible solutions, we looked, we got rid of the RDBMS world in a second, as Doug mentioned in the beginning. Both Oracle and MySQL are not relevant in this discussion, so obviously we looked in the NoSQL world. And we had three main options that we looked at. Cassandra is one of the options. We've been using Cassandra in production for, 4 or 5 years, give or take, for multiple services. So we are using Cassandra. We're familiar. We have knowledge about Cassandra. We know what works and what doesn't work in Cassandra. We looked at Couchbase and we looked at MongoDB. And I guess in the document store world, these are the two main competitors in a way. So we looked on all of the three options, and I'll tell you why we chose Couchbase. And feel free to ask questions, guys. So why did we pick Couchbase? So first of all, performance. Couchbase is really fast and can scale really nice, high throughput. We'll talk about ops per second. But as far as scalability, I think this is the main selling point of Couchbase, at least for LivePerson, because we're dealing with a lot of data. We needed the resiliency. We needed something as a resilient solution. We needed a solution that can scale linear. It's very important for us. We okay with adding nodes and adding servers, but we needed a linear scale. We searched for something that is schemaless. We wanted fast development. We didn't want schemas. We wanted to do a very fast development. We do need searchable capabilities to set queries, to be able to set queries, have pagination, sorting, all of those options. We didn't want to develop on the application side. We wanted the data store to do that. I think Couchbase, the one advantage that it has, it supports both kind of key value store and document store. So the fact that we could do document store in one hand and we could do simple kind of mem cache on the other hand was really a nice upside for us. It supports cross data center application, which is a key item for LivePerson. Again, we're global, have 4 data centers, etc. We needed something simple, and we needed a solution, and that's why we kind of went with Couchbase. So this shows you a little bit of the entire system. I told you this system is called visitor list, this system that aggregates this real-time information. So the way that it goes is a very kind of simple view of the process. It's data flow. It's not like topology and everything. But the way that this system works, so on one hand, we got the visitor, could be in browser, could be web, could be mobile. The browsing our customer site. Let me just, get rid of this. The browsing the site, and we have what we call the visitor monitoring service. Those are thousands of servers that essentially listen to the customers and collect information in real time. On our customer site, we got some JavaScript code that's essentially kind of listened to, very similar to kind of Google Analytics in a way, conceptually. But essentially, we track the behavior of the customer or the visitors on their pages, if they're waiting, if they're clicking. So we monitor all of this information is being stored to our visitor monitoring service. This service kind of streamlines the data through Kafka, which is our event bus. And then it goes to what we call the STOM topology. The STOM topology is a piece of code that essentially listens to those events, filter specific events that interest this specific application, and essentially process the information and storing it in Couchbase. And I'll explain the structure and the document structure and the design and all of that in a second. On the other hand, we got those customer representative, said thousands of agents that in real time the system keep pulling, essentially call some API layer, essentially get certain queries all the time, refresh the information on the other side, and essentially go to Couchbase, do a query, return it to the end user, the web agent. So at a high level, this is the basic system. So as far as kind of data design and numbers a little bit. So for us, every user is being represented by a document. A document will contain a bunch of attributes, somewhere in the range of 15 to 20 attributes. It can say when the user logged into the site, what type of pages did it browse on, the state of the user, if the user is chatting, waiting, engage with a specific engagement. So all of that information, all of that information is being stored in a single document. And as I said, we're a SaaS platform, so essentially Couchbase, one bucket contains the information for all of our customers. So we always have an account ID, so we can query the information for a specific account ID, and we'll see that in a second. So when we come to numbers, and I'll just say one caveat, this system was developed in the last 5 months. It's been deployed in production in our kind of staging environment in the past month and a half. The way that we do rollouts in LivePerson for those kind of systems, we do a gradual rollout. So the numbers that you see here are going to be the peak numbers that we're going to encounter in a few months from now. So we do a kind of a gradual rollout. We kind of, instead of doing a lab, a very kind of isolated lab, our approach is write something after you did a POC and start streaming water, what we call stream water, to that system just to see how the system behaves. You can do everything in a lab, but real life has different use cases sometimes. So as far as the average document size for us is about 10K. The key size is about 10 characters. We have about 5-second level indexes. Those are the main indexes that have been queried on the other side, on the API side. And when we get to the final rollout, so the throughput, well, the numbers and the throughput, we're going to talk about somewhere in the range of 1 million concurrent active document or active visitors in a single time. And the system is designed to scale to 100K ops per second. We think in the next 3 to 4 months, we're going to get to 40, 50K. That's the numbers that we're aiming to. And then there's going to gradual rollout throughout the high season. High season LivePerson, since most of our customers are geared through e-commerce, is the holiday season in the States. Black Friday, Cyber Monday, if you know those terms.
How many servers?
So I'll talk about sizing. It's a great question. I'll talk about sizing a little bit. We started the rollout with a well, we have 4 different clusters for each data center. We started with a simple 3-node clusters, 64 gigabit machine with hard disk, not SSD, hard drives. Based on the initial, we ran some analysis, worked with the Couchbase guys a lot to give us proportions of sizing. By the current estimation right now, then each cluster should get to about, let's say, in the range of 6 to 7 different nodes. And then it really depends on, and I'm going to speak about it, but it also depends on the cross data center replication, because replication adds some factors into it. Yeah. But when I said 6, 7 nodes, probably SSD we're going to play also. It's going to be another factor that we'll have to replace the servers.
And the 6, 7 node is in each data center?
Each data center.
So they take a quarter of this?
Not necessarily. It's not really balanced. So that's why I'm saying, that's why we don't know the final numbers, because we're kind of changing some of the architecture. So we need to understand where the how the traffic is going to be distributed. But yeah, give or take, it's going to be distributed across some of the data centers. Generally speaking, we have 2 main zones. We have the US North America zone on one hand and the EU zone on the other hand. Our main market and the numbers, probably most of those traffic will be on the North America market. But we also have Asia markets now. So I'm going to show a little bit about kind of code snippets that we do. So the way that we do, one of the key factors we understood when we started to design this system is the fact that essentially this system, let's say unlike logging system, it's not a system that continues to do insert or appends. The key factor here, because every document represents a visitor, is the fact that every event that represents an event on the visitor side will have to do a lot of updates versus just inserting content into it. And so it means that every time we get an event that represents a visitor on one side, we have to do get, set the right values to the JSON, and then post it back. So that's a very important thing to do. And when it comes to performance, like one thing that we encountered, let's say versus Mongo does really nice inserts. When it comes to updates, it has some other issues. So that, for example, once we understood that we'll do a lot of updates, this was a key factor for us for choosing Couchbase. Tag mentioned views and how do you use views. So for us, we do use the views. We don't use reduce function for now. We use views just to set essentially the indexes and the sorting. So you can see an example here, for example. This is for us, the key, the index is a kind of a compound key of account ID. As I said, it's kind of a multi-tenant databases. Order is some kind of a sequence that represents the user state. And we wanted also to sort it by the visitor start time, so we can see a sorted list on the front end. But again, we don't use reduce. For us, it's just for the indexing. And you can see this is the code, but on the top you can see, as Tuck showed it a few minutes ago in the UI, this is essentially simulate the query that we're doing. And what you see over there is a range query of the account that we want to present, and the range 0 to 9 is basically the order or all of the user state that we can see. And below that, you can see just a piece of code that essentially simulate the same REST query that you see on the top. So I'm going to speak a little bit about cross data center replication. So today, as I said, the system is in production, and we are using unidirectional replication. For us right now, the system is kind of in a DR mode. So we, on one data center is an active data center, and on the other hand is a data recovery. So we do that, the streaming, we do that already. In the future, and I'm probably, that's the kind of September, October timeframe, we're going to enable bidirectional replication, because some of the traffic we're going to be on the East Coast data center, some of the traffic going to be on the West Coast data center. So actually the examples that Tuck shows are not kind of taking out of context. It's a real life examples. Couple of the insights that we had is for us, the key space is going to be the same, meaning we're going to update a document either on the East Coast or in the West Coast. We're not going to do an update on both coasts. So for us, we're kind of avoiding duplication. The way that Couchbase works is kind of the last revision wins in a way. So for us, it's a non-issue because we either update it on one data center or on another. And when you ask me about sizing, there's an impact on the cluster size. We don't know to evaluate exactly what will be the impact, but clearly updating and doing the replication going to increase the load on each one of the cluster. So we definitely take it into account. So kind of couple of insights that we learned till today after working with Couchbase for a few months. So for us, every new visitor that comes to the site represents a new document. When the visitor leaves the site, obviously is not an active visitor anymore, so we kind of delete. Initially, when we started to design the system, we used kind of delete, remove it from Couchbase. What we learned, and that's based on the Couchbase guys' feedback, is that we probably need to use kind of a TTL and let Couchbase clean or compact and remove those documents at once versus telling, because the system is a very, the throughput is a very high throughput and there is a lot of updates, inserts, and delete. They didn't want us to create more load on the system and create a lot of delete. So we use kind of a TTL and we have a logical or kind of a soft delete in the system. We use the view to filter those documents out from the view. So that's one insight that we learned. For us, the use case that we have says the working set probably going to get close to 100% because it's a real-time system. It's not a statistical system. It's a real-time system. So RAM is, of course, one consideration, and also SSDs. If you talk to the Couchbase guys, I'm sure Tag knows those conversations with the customers. They're always pushing you to the SSD, which makes sense in a way. But that's one thing that we need to take it into account. And one piece of advice that we learn is move to production as soon as you can. Even if, don't spend, that's my kind of 2 cents, don't spend too much time in a lab because you never see like real life examples. So that's for us one key statement. So a little bit about what so this is the first system that we did with Couchbase, and there are a few other use cases that we kind of looking at Couchbase. One of them is working with session state. So for the monitoring system today, most of our session state is kind of in-memory stateful machines. So we're looking at Couchbase to essentially as a caching layer. We're looking at Couchbase as what we call cross-session states because we're learning about the customers over time. And of course, a simple caching layer for some of our RDBMS system to offload work from the MySQL world. That's about it.